So now look at the decision tree construction algorithms, right? So how would we do that? We would start with the training set. And what is the training set? It's pre-classified records of loan customers, right? So what is basically a training set? It consists of records that have been classified previously, right? So what does each customer record contain? It contains independent variables which are income, time employed, debt. It also contains dependent variable outcome of past loan, right? So we find the independent variable that best splits the records into groups where one single class, low risk, high risk, predominates, right? So what is the measure used? Entropy of information. Diversity is used to find out. So what is the objective? We want to find the maximum value of diversity before minus diversity left plus diversity right. And what is this left and right? Because we are talking from the point of view of the trees. Left branch and right branch, okay. So we repeat recursively to generate lower levels of tree. So we move towards the upper level recursively in this algorithm. So what are the pros and cons of the decision trees? Pros: one of the most intuitive techniques. People really like decision trees, right? So it's very intuitive and very straightforward. Really helps to get some intuition as to what is going on, right? We have a better view of the picture that's going on. Can lead to direct actions, decision procedures. What are the cons now? Independent variables are not always the best separators. Maybe some of them are correlated, right? Redundant. So correlation is one of the properties that are very important in these kinds of analysis. We'll look at it later on also. So maybe the best splitter is the linear combination of those variables, right? For example, factor analysis. Again, some of these terms we will be dealing with extensively in the coming lectures. So we now start our discussion about the neural networks. Neural network is a powerful method for constructing predictive models, right? So they can predict or classify, right? And it has got the nodes, right? Input layer, this is the input layer, this is the output layer, and this can be all the layers that are between the input layer and the output layer can be classified as a hidden layer, right? So activation function results are multiplied by the weight, respective weight, and passed on to the output. So weights are determined using a training set, that is the number of test cases where both the inputs and the outputs are known, right? So basically the weights is the important aspect in a neural network, and when we mean by training the weights, we are actually finding suitable values for the weights depending on the input training set that has been provided to the neural network. And again, one more important point is that the higher the number of inputs or the bigger the training set of a neural network, the better it would become at classifying the outputs. So how we can do that? We can build a neural net to calculate the credit risk for loan applicants. So what would be the inputs? Annual income, loan amount, loan duration. And outputs would be the probability of default. 0 for no default and 1 for default. And what would be the training set in this? Data from past customers with known outcomes. So given the customer's annual income, loan amount and loan duration, the model would be able to predict whether the probability of default would be there or not. That's why we can find out. So we start from an initial estimate for the weights, right? We assume the weights of the neural network and then we feed the independent variables for the first record into inputs 1 and 2. Compare with output and calculate the error. And based on the error, we update the estimates of weight by back propagation. So this process is called back propagation. From we take the inputs, we calculate the outputs, then we compare with the known output, and the error is back propagated through the network to calculate or to adjust the weights. So this is how the neural network is working. So we repeat with next training set record until the model converges, right? And by converging we mean the rate, the error percentage becomes less and less. We are minimizing the error, right? So what are the pros and cons of neural networks? The pros is versatile, gives good results in complicated domains. Cons, neural networks cannot explain the data, they can just classify. And all inputs and outputs must be messaged to 0 and 1. That is the idea. So now we can take a look at the data mining process. In data mining process, what we do, we define the business problem, we build the data mining database. Of course, it would involve the data warehouse. We'll explore the data, we'll prepare the data for modeling, we'll build the model, we evaluate the model, and we deploy the model and the results that we get. So here is the comparison of some of the data mining techniques, right? Standard statistics can be used for classification, estimation, prediction, affinity grouping, clustering, description, all of these. While market basket analysis can be used for prediction, affinity grouping, clustering and description. They cannot be used for classification and they cannot be used for estimation. Similar is the different pros and cons of the other types. Neural networks can be used for classification, they can be used for estimation, they can be used for prediction and clustering. They cannot be used for affinity grouping and description of the data. So when we evaluate the various techniques, these are the results that we get, right? These are the grades against the respective things we want that we can have, right? The higher the grade, the better the model is at a particular task. For example, market basket analysis is good at understanding model, good for ease of training model. Application is extra great in this. Generality, it does not score high. For utility, it is okay. For availability, it is okay. So hence, these are the analysis of the different techniques. So now let's look at some of the points of what basically is a data warehouse. Data mining has a hard requirement for clean and consistent data. So for mining the data must be clean and consistent. So that is one of the challenges. Decision support data. This is called basically the decision support data, and it is found in many different databases within a company, outside the company. And it is often inconsistent and unclean. So in practical terms, locating and integrating all this information in real time is very difficult. So remember, we discussed that data warehouse contains historic data. So we create separate repositories of data for decision support, and they contain historical data, transactional data that has been collected over time. And this is the term data warehouse. So data warehousing architecture includes operational data, which deals with who, what, where and when. This is basically the operational database, everyday database, transactional database that is happening. Okay? So then we summarize by who, what, where and when. This is called summary data. Then we design the database schema with the physical layout of the data tables, fields, indexes and types. Then we have the metadata, which is the logical model and mapping to physical layout and sources, right? Metadata is data about the data, remember. And finally we have the business tools, which are what's been learned from the data. So this is the data size given by the abstraction level. So this has got the highest abstraction level, which is the business rules. So what are the data warehousing considerations? What data to include, right? And how to reconcile inconsistencies, and how often to update. So these are the three key questions in a data warehouse. So what are the trends in business intelligence? Current trends, right? Text mining, which is mining patterns from unstructured data text, for example, from the web. Software agent technologies, which is the business intelligence on behalf of the customer. Agents learn the preferences and behavior of their human master in order to search the web and recommend products, compare prices and other attributes and select providers, and automatically negotiate. So what does this mean for vendors? For vendors, it means what? Profit, right? Sales. So to delve deeper, there are some of the books that can be discussed. I would be sharing some standard books also. I have placed them on the shared folder already, so you can take a look at those. That's basically the end of the introductory portion. Thanks for watching.